I am Anil Kumar. Welcome to my series on inverse trigonometric functions. We'll talk about many examples where we'll see how to work with the compound angles and simplify them. In case you want to learn from me, you can always write email to the address given. You can also check our website for some new videos being uploaded. So in this video, we'll discuss some compound angle identities. We'll explore the half angle formulas, learn these strategies to simplify such expressions. We'll also work with the absolute functions and the related domain interpretation. To summarize, we have these formulas for compound angle as you know. Sine A plus B or A minus B could be written as sine A cos B plus minus cos A sine B. Similarly, cos A plus B could be written as cos A cos B plus minus sine A sine B. If it is cos A minus B, in that case, cos A cos B plus sine A sine B. For tan, the formula is given to you. Perfect. Now, from these formulas, you can also derive the double angle formulas, which are cos 2x is cos square x minus sine square x. It can also be written as 2 cos square x minus 1 or 1 minus 2 sine square x. Now, these two formulas, which are right there, help us to get the formulas for the other related functions, right? So, for example, from here we can rearrange, and what we can write here is that 2 cos square x is equal to 1 plus cos 2x. And from here we can write 2 sine square x is equal to 1 minus cos 2x. Very important formula which we are going to use many times. And if you do the square root, then you get these formulas, correct? So you get these formulas, all are related. To show you how we are going to work, here's an example. If I have cos x over 1 plus sin x, in that case, cos x could be written as, we are using the first formula, right? Cos 2x, cos x could be written as cos square x by 2 minus sin square x by 2. 1 plus sin x. 1 can be written as cos square x by 2 plus sin square x by 2. That is for 1. And for sin x, we can write 2 sin x by 2 cos x by 2. Now the terms in the numerator and denominator can be factored, correct? I have not shown you that step. So it is like a square minus b square. You could factor these terms, and the denominator is a plus b whole square. So a plus b cancel, and what you get is a simplified expression. And you can divide by cos square x by 2 to get this particular expression, which can later be written as tan of pi by 4 minus x by 2. Tan of pi by 4 is 1, correct? So 1 minus, you see that formula relation, correct? So it is just to give you a summary of the level of compound angle manipulations which you have to do, right? To solve these questions. Perfect. So get ready with this. Special triangles only given to you for ready reference to evaluate the values required. Clear? Okay, so now let's begin with our example 1. Now in example 1, we have to simplify tan inverse of cos x minus sin x divided by cos x plus sin x. We'll be working in the domain x within minus plus by pi by 4 to plus pi by 4. Correct? So that is the domain in which we are going to work, tan inverse of cos x minus sin x. You can divide by cos x on both the sides, getting 1 minus tan x over 1 plus tan x. And this expression is tan of pi by 4 minus x. So tan inverse of tan of pi by 4 minus x is pi by 4 minus x in the given domain, right? So how do we work with domain? Let's see that part also. So this is the domain given to us, correct? So what we do here is we know that this is true if we are working in when x is between minus pi by 2 to plus pi by 2, correct? In that case, we know that tan inverse of tan x is x, correct? That is where the inverse of tangent function is defined, right? That is where it is one-to-one function. Perfect. So, in this domain, where x is greater than minus pi by 4 less than pi by 4, what we can do is multiply by minus. When you do that, all the sign reverses. Do you see that? When you multiply by minus, the sign reverses. So we get pi by 4 is greater than minus pi minus x, which is greater than minus pi by 4. And now we are interested in understanding what is the domain for pi by 4 minus x. So add pi by 4. When you add pi by 4, this term becomes 0. So we written this as 0. And pi by 4 minus x is less than pi by 2. So we are now working in this particular domain, and that is within our domain, and therefore tan inverse x over tan x is basically x, correct? So that is why we got this answer, correct? So you have to work on this and then you get this result. Is that clear to you? Here I have shown you in details how do we get this part of tan of pi by 4 minus x. You know this formula, which is tan a plus b is tan a plus tan b, 1 minus tan a tan b. For a equals to pi by 4, right? We know tan pi by 4 is 1 and we wrote b as x, correct? We get the formula which is right there. And that is how we'll work with it, correct? This was derived for plus, and with minus you get the same result with the negative sign here. So if you have negative here, in that case this is negative, that is positive, this is negative, and this is negative, and that is positive. And that is what the result was, correct? So that is how you have to work with them. So I hope these steps are clear. Let's move on and take the next example. The next one is tan inverse of square root of 1 minus cosecant x divided by 1 plus cosecant x. Now, 1 minus cosecant x over 1 plus cos, it is actually typing error, it's cos x, sorry. It is not cosecant x, it rewrite it. So it is tan inverse of within square root 1 minus cos x over 1 plus cos x. Okay. Okay, so we have 1, it is not cosecant but cos x, okay. So 1 minus cos x is 2 sine square x by 2, 1 plus cos x is 2 cos square x by 2. So clearly you get square root of tan square x by 2. Now square root of tan square x by 2 is absolute value of tan x by 2. You're working in the domain 0 to pi for x. For x by 2, it will be 0 to pi by 2. And within 0 to pi by 2, we know tangent value is positive, and therefore absolute value of tan x by 2 will be x by 2. Correct? So we get our result, which is x by 2. Now let us take the third example, which is simplify tan inverse of cos x over 1 minus sin x, where x is between minus pi by 2 to plus pi by 2. Correct? So we have tan inverse of cos x over 1 minus sin x within this interval of minus pi by 2 to plus pi by 2. We can write cos x as using the double angle formula within the terms of half angle. Cos square x by 2 minus sin square x by 2. 1 can be written as cos square x by 2 plus sin square x by 2. Sin x can be written as 2 sin x by 2 cos x by 2. Correct? So we have used these double angle formulas, written the expression in half angle. Perfect? Now, the numerator is kind of a square minus b square. I could factor this as a plus b times a minus b, correct? So we have written this as cos of x by 2 plus sine of x by 2 times cos of x by 2 minus sine of x by 2. The denominator is a perfect square. So it is written as cos of x by 2 minus sine of x by 2 whole square. So clearly one of the terms get cancelled. When that happens, you get tan inverse of cos x by 2 plus sin x by 2 divided by cos of x by 2 minus sine of x by 2. Now, dividing by cos theta by 2, we get 1 plus tan x by 2. and 1 minus tan x by 2. Correct? Now this is a very important expression which we worked with earlier also. You can use tan a plus b formula just to give you a hint about it. So if you have a as pi by 4, let's replace a with pi by 4. Then tan of pi by 4 is 1. You get this as 1. And let's replace b with x, right? In our case, x by 2, right? In this expression, I'm using x. In that case, the formula reduces to, instead of tan a plus b, we get tan pi by 4 plus x, we get this formula, right? If x is x by 2, then you get what this is. So basically, tan inverse of 1 plus tan x by 2 divided by 1 minus tan x by 2 is tan inverse of tan pi by 4 plus x by 2. Okay? So you get tan theta, tan inverse of tan theta. Now let's work also the domain to simplify this. The domain given to us is between minus x by 2 to plus x by 2. So if I divide by 2, right? So if I divide by 2, then we get minus pi by 4 to pi by 4. Now we are interested in finding the domain for pi by 4 plus x by 2. So add pi by 4. When you add pi by 4, you get the domain for this particular argument as between 0 to pi by 2. Within this domain, tan of tan inverse theta is theta itself, and therefore we get the answer, which is pi by 4 plus x by 2. Correct? So that is how we are going to solve such question. I hope it makes sense. Correct? Let's take up the next example, which is example 4. Simplify tan inverse of 1 plus cos x square root plus square root of 1 minus cos x. And we have a similar expression with a negative sign in the denominator. X is between 0 to pi by 2. How do we solve this? So you have to work with the compound angle formulas to get these answers, correct? Square root of 1 plus cos x. So 1 plus cos x can be written as 2 cos square x by 2, and 1 minus cos x can be written as 2 sin square x by 2. So working with these formulas help you to get this particular expression, correct? So therefore, working with compound angle, remembering those formulas is kind of important. So similarly, we get our denominator with a negative sign. Now, square root of x squared, as you know, is absolute value of x. So, we have written this as absolute value of cos x by 2 and sin x by 2. Square root 2 cancels, so we get a term which is much simpler. We are given the domain between 0 to pi by 2. Within this domain, we know that the absolute function of cos x by 2 and sin x by 2 is positive, and therefore it has been written as cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2, as we did last time. We'll divide by cos x by 2, tan inverse of 1 plus tan x by 2 and 1 minus tan x by 2 we will get. This can be written as tan of pi by 4 plus x by 2, right? Since plus is in the numerator. Now, tan of tan inverse this should be equal to that. Perfect. Well, let's work with the domain itself to justify our answer. You know, x is between 0 to pi by 2. Divide by 2, you get between 0 to pi by 4, correct? And adding pi by 4, we get a domain between pi by 4 and pi by 2. Within this domain, the absolute value of tan of tan x pi by 4, this is tan theta, right? So that is how we actually derive it. Okay, let's take up the next example, which is simplify tan inverse of 1 plus cos x plus 1 minus cos x divided by 1 plus cos x minus 1 minus cos x, correct? So this time, slightly, it is the same question. Okay, right. So, but we have a different domain. Okay, this is important. So we have another domain. So we'll now work with the domain which is from pi to 3 pi by 2, right? Let's understand the difference. Earlier case, the domain was between 0 to pi by 2, correct? Now we are working in the domain from pi to 3 pi by 2. That is important to understand, right? Now we are working in the domain pi to 3 pi by 2. Okay, so we are working in this domain. Earlier, We were working in 0 to pi by 2. Is that clear to you? So that makes huge difference. In this particular domain, the absolute value will change, right? So now we'll work on this and see how it becomes different, right? So the domain is from pi to 3 pi by 2. Correct. Now it is good. So we'll do the similar calculations as we did. We are going to write them in 2 cos square x by 2, 2 sine square x by 2, get all that. Remember, important thing here is that we know square root of x square is absolute value of x. And so we got this absolute value of x. Now, how do you define absolute value of x? This is basically equal to either plus x or minus x, depending on what is the value of x, correct? That is what is important. Now, that is from the domain itself. We know now that x is between pi to 3 pi by 2, correct? What is x by 2? We're working in x by 2. So pi by 2 and 3 pi by 4. So when you are working in this domain, which is from pi by 2 to 3 pi by 4, that means in this region. Is that clear to you? So pi by 2 and 3 pi by 4 is this particular portion where using the cost rule, sine is positive but tan and cosine are negative, and therefore for sine we'll write positive and for cosine we'll write negative. Do you see this negative term here? So cos of x by 2 is equals to minus cos of x by 2. This is critical to understand. And sine of x by 2 is positive sine of x by 2. That gives you the result. You get the idea. So when we change the domain as it has been done here to understand its influence, we get the expression which is kind of like this. You can take minus, cancel minus, and then write this as cos of x by 2 minus sine of x by 2 over cos of x by 2 plus sine of x by 2. So you get 1 minus tan x by 2 or 1 plus tan x by 2. That gives you pi by 4 minus x by 2. Clear? That is what you get, right? Now let's also work in the domain for pi by 4 minus x by 2 before getting the answer. So x is given to us between pi and 3 pi by 2. Minus, when you do minus, right, you have to interchange the sign. So I divided by 2 and made it minus. So minus pi by 2, sign becomes greater than now as shown here. Now we are looking into, we'll add pi by 4. When you add pi by 4 to this, you get what? You get your interval. Between adding pi by 4, you get minus pi by 2 to minus pi by 4. So that is within our interval, which gives you tan inverse of tan theta as theta itself. So the answer is pi by 4 minus x by 2. Correct? So that is how we get our solution. Very important exercise to understand how the domain influences the working. Okay? Let's take up example 6 now. In example 6, the question is cot inverse of square root of 1 plus sin x plus 1 minus sin x. So instead of cos, we have the expression in sin x this time, cot inverse of that. Correct. So that is what our expression is. Now, we have seen also how do we work with 1 plus minus sin x. 1 is written as cos square x by 2 sin square x by 2, and sin x is written as 2 sin x by 2 cos x by 2, which is a perfect square of cos x by 2 plus sin x by 2. Correct? So let's begin with this expression 1 plus sin x plus 1 minus sin x over 1 plus sin x 1 minus sin x, all in square roots. We're working in the domain 0 to pi by 2. Now, as shown above, 1 plus sin x can be written as cos x by 2 plus sin x by 2 whole square, and 1 minus sin x will be cos x by 2 minus sin x by 2 whole square. Is that clear to you? So it's kind of important to understand that we have used this derivation to simplify the expression 1 plus or minus sin x. Correct? Once you get that, in that case, we'll write this as in square root of x square as the absolute value of x. So we got cos x by 2 plus sin x by 2 absolute value plus absolute value of cos x by 2 minus sin x by 2. Now these absolute values we have to work within the domain 0 to pi by 2. So if x is between 0 to pi by 2, then x by 2 is between 0 to pi by 4. In that case, we know the absolute values will be positive only, so we wrote them as cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2. Simplifying numerator and denominator, we get 2 cos x by 2 divided by 2 sin x by 2, which is cotangent x by 2. So within our interval, we know that should be equal to x by 2 itself, and so we get our answer as x by 2. Is that clear to you? So that is how we are going to solve this example. So I hope that helps to understand how do we work with these trigonometric functions, right? We have seen how do we simplify from these compound angle formulas, get the results, correct? That's kind of very important. So I'd like you to review your skills on compound angles, so that you effectively work with trigonometric inverse functions. Perfect. So that's kind of a review on compound angle with trigonometric inverse function. This particular sheet gives you all the formulas which you might need and strategies to solve similar questions. I hope that helps. Once again, you can always contact me on the email address given and check my website for the new videos being uploaded. Thanks for your time and all the best.